All right, I've got one more optimization problem here I want to do for you. This is a little bit different in flavor from the other one, as you'll see why here. But it says to find the area of the largest rectangle that has its top two vertices on the parabola y equals 32 minus 2x squared, and its bottom two vertices on the x-axis. So I've got this parabola. This is a downward opening parabola. It's the y-axis here up at 32, and it goes down from there. Okay, and I want to put a rectangle in there where the top two vertices of the rectangle are on the parabola and the bottom two vertices are on the x-axis. Okay, so it looks something like this. Now there's different ways I could have drawn that rectangle, right? Because it could be like this, it could be like this. But in any of the cases, the corners here are on the parabola. Right? Now, what makes this different from the other ones, in my view, is that in the three that we've done so far, you pick your variables. You decide what the variables are. But here, we're given an equation of a curve. The variables are already picked for us. There's an x-axis here, and there's a y-axis. What I need to do then is use that coordinate system that's already given to me to describe the things that I'm trying to find here. So in particular, it says to find the area of the largest rectangle. So I'm trying to maximize the area. I need area equals. I think I've done area 3 times now, haven't I? Anyway, the area to maximize this here. So looking at let's just look at one of those rectangles. Let me erase this one. Oops. And this one. So I'm just looking at that one rectangle there. Notice x and y are already given. That is, that when I say that this point right here is x comma y, the x-coordinate is the distance from the y-axis, and the y-coordinate is the distance up here. That's x and that's y. That's what those variables already stand for. Right? Now the area of that rectangle is the width times the height here, and if I had drawn this accurately, it would look a little better. I notice here that my axis isn't even remotely straight, so let me see if I can make it straighter. The point is that there should be some symmetry about that axis, that x, this side is the same distance that side, so that the width across that rectangle is actually 2x and the height is y. Okay. I've seen people do this differently, where they say that the width is w and the height is h, and then they somehow convert those into x's and y's. And because this is already given to me an equation with x's and y's, let's just use those variables for what they are. X is this distance from the y-axis over, and y is the distance from the x-axis up. Okay. So anyway, now I have my area in terms of x and y, but I need only one variable. Right? In a Calc 3 class, we'll be able to use 2 variables, but this is Calc 1. So I got to get rid of them. But there's a relationship, because this point, xy, is always on that parabola. If you're always on that parabola, then you satisfy this equation. And so I know that y is equal to 32 minus 2x squared. So I can plug that in here. So this is 2x times 32 minus 2x squared. So my area function, as a function of just one variable now, the x-coordinate of this point right there, is, multiplying this through, I've got 64x minus 4x cubed. Do I have any restrictions on x, any endpoints that I might have to keep in mind? Well, yeah, I think I do. X could be as small as 0, and then you've got this really tall, oops, what just happened there? And then you've got this really tall, skinny rectangle, right? Or x could be as much as whatever that point is right there. So where does this thing hit the x-axis? When does this equal to 0? When is 32 equal to 2x squared? X squared would equal 16. So plus or minus 4. So it looks like x could be as big as 4. Now I think you'll agree with me that the area, actually you can just plug it in. Plug a 0 in for x, and you're going to get an area of 0. Plug a 4 in for x, and you're going to get an area of 0. Those are minimum areas. I want to maximize the area, so I'm going to look for my critical points. And my critical points happen when the derivative is 0 or when the derivative is undefined. So here we go. Take the derivative. I've got 64 minus 12x squared. Set that equal to 0. 0 is equal to 64 minus 12x squared. And I'm setting it equal to 0 because I'm looking for a max or a min, right? And that's where they happen, is when the derivative is equal to 0. I'm looking for a max in this case. So 12x squared equals 64. X squared equals 64 divided by 12. Did I pick something nice? I don't think I did. 64 divided by 12. I don't know why I can't do that in my head. 5 1/3. So that's, my calculator's telling me 5 1/3, which is 15 16/3. So anyway, x is 4 over the square root of 3. 4 over the square root of 3. Well, that's ugly. But what did I ask for? Did I ask for x? Did I ask for y? Find the area of the largest rectangle. So what I need to do now is to plug that into my area function. So the area is 64 times 4 over the square root of 3 minus 4 times 4 over the square root of 3 cubed, and that's equal to 89.2968. And did I ever give units? Well, square units, whatever they are, right? Because that was length times width. So anyway, that is the maximum area that you can get from a rectangle with its vertices on the parabola. There are various problems that you'll see as you work through the problems in the book where they inscribe, sometimes they'll do a sphere and you're inscribing a cylinder inside the sphere. Sometimes you're doing an ellipse and you're trying to put a rectangle inside an ellipse. I mean, there's all different sorts of variations. But the idea is you've got a coordinate system, either maybe an xy coordinate system, and you've got the equation of a circle that when you rotate it will generate the sphere. That already gives you variables to work with because the coordinates of a point would be x comma y, and then you can describe everything about the situation in terms of those variables, right? So for instance, if this was a sphere and this was a cylinder inside, then I got a point right here, x and the y. The radius of the cylinder would be x, the height would be 2y, right? So there's all sorts of things like that. If you've already got an equation of a curve, you've got an xy coordinate system, use x and y to describe all the pieces you need of the situation. Anyway, there's another optimization problem for you.